Section 3.2 is called the derivative as a function. The derivative of a function f with respect to x is the function f prime defined by the rule f prime of x equals the limit of f of x plus h minus f of x divided by h as h approaches 0. Different ways to write the derivative is by using these notations here. So like this one here, this is the derivative of f of x with respect to x. This one you can say f prime of x. This one you can say y prime. This one is dy dx. And again, this one, the derivative of the function with respect to x. And here I gave you an example on how to set up the definition of derivative. F prime of x equals the limit of f of x plus h minus f of x divided by h as h approaches 0. So you're given a function. The original function is f of x equals 3x squared minus 5x plus 8. Wherever you see x, you're going to replace it with x plus h to get that f of x plus h. Some things that we need to do on the side work, is FOIL. X plus h squared means x plus h times x plus h. And so when we FOIL, we get x squared plus xh plus xh plus h squared. Combine like terms, so this here becomes plus 2xh plus h squared. And so simplifying the top, we have 3 parentheses x squared plus 2xh plus h squared minus 5x plus h plus 8 minus 3x squared minus 5x plus 8. Distribute the 3, distribute the negative 5, distribute the negative. 3x squared plus 6xh plus 3h squared. Distribute the negative 5, we get negative 5x minus 5h. Bring down the plus 8. Distribute the negative, we get negative 3x squared plus 5x minus 8. Combine like terms. This cancels with this cancels with this, and this cancels with that. And so notice how we are left with 6xh plus 3h squared minus 5h. Each of the terms have an h in common, so you can factor it out. And so we have 6x plus 3h minus 5 inside the parentheses. And so that is what is happening over here in the second step. Basically, you factor out the h, and what happens when you divide it by h? The one on the bottom, those two cancel. And so we get the limit as h approaches 0 of 6x plus 3h minus 5. Using direct substitution, wherever you see h plug in 0, we get 6x plus 3 times 0 minus 5. And so the final answer is 6x minus 5. And that is the derivative of the function. Example 1. Let f of x equals 2x squared minus 10x plus 4. This is a quadratic function. A. Use the definition of derivative as a function to find the derivative. The derivative is equal to the limit as h approaches 0 of something. Let's find that something. First, let's start with the definition. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. Let's find f of x plus h. That is 2 parentheses x plus h squared minus 10 times x plus h plus 4. From the previous page, I know that x plus h squared is x squared plus 2xh plus h squared. If I distribute the negative 10, I get negative 10x minus 10h plus 4. Distribute the 2, That is 2h squared plus 4xh plus 2h squared minus 10x minus 10h plus 4. So that is our f of x plus h minus f of x. So I'm just going to do it as a side work. So what happens when I subtract f of x? We just got all this crazy stuff minus f of x, which is the original. The original is 2x squared minus 10x plus 4. We have to distribute a negative, which we get negative 2x squared plus 10x minus 4. And we need to combine like terms. So let's see what happens. This cancels with that. This cancels with this. And this cancels with that. I'm just being lazy. I don't want to write that whole thing again. That's why I just like pretend I put it here in the box. And so we have 4xh plus 2h squared minus 10h. So going back to our definition, the derivative is equal to the limit as h approaches 0 of 4xh plus 2h squared minus 10h divided by h. And so that is what goes in the first box. Just like the previous one, each of the terms on top have an h in common, so that is going to cancel with the h on the bottom. And so we end up with the limit as h approaches 0 of 4x plus 2h. Don't forget that you still have an h because that was 2h squared minus 10. And then we apply direct substitution. We get 4x plus 2 times 0 minus 10 is 4x minus 10. And that is the derivative. Oh, I think we need more space. That's okay. Find the derivative at x equals negative 2. So now you have the derivative function. You can plug in any value of x. F prime of negative 2 is 4 times negative 2 minus 10, and that is negative 18. So the derivative at negative 2 is negative 18. Write the equation of the tangent line at x equals negative 2 in point-slope form. Well, that is good because point-slope form is just y minus y1 equals m times x minus x1. And we almost have everything that we need for that one. So I'm just going to do it over here. The slope of the tangent line at x equals negative 2, that is f prime of negative 2. And we found that that is negative 18. The point of interest, that is negative 2 comma something. So what we need to do is go back to the original function and plug in that negative 2 to find the y. So 2 times negative 2 to the second power minus 10 times negative 2 plus 4. So when x is negative 2, the y is 32. And so we're ready to find that equation. Y minus y1, so minus 32, equals the slope of the tangent, negative 18, parentheses, x minus x1. So x1 is negative 2. Double negative makes it a positive 2. And this is our equation.